Hello everyone and welcome to this next lecture in the Build DeepSeek from Scratch series. Today, my main agenda is to cover three things. First, we are going to look at what exactly is DeepSeek. Second, we are going to look at what makes DeepSeek so special and why is everyone talking about it? What are the technical details which make DeepSeek so special? And the third thing which we are going to look at is what is the plan in this lecture series, what we are going to learn, and what is the sequence in which we are going to learn about different topics. So let's get started. First, what is DeepSeek? Essentially, DeepSeek is a Chinese company which builds large language models. And before we dive any deeper, first let me give you a quick overview of what large language models essentially are. All of you would have interacted with ChatGPT, right? I can go to ChatGPT right now, and let's say I can ask that make make a travel plan for me to visit Italy, and then ChatGPT will come up with this travel plan. This is a large language model, but one thing to keep in mind is that at the heart of it, what a large language model is that it's an engine which takes in a sequence of words and then it gives a probability of what's the most likely next token. And when such tokens are aggregated together, it forms sentences such as what we see here right now. So essentially, large language models are probabilistic engines for predicting the next token. This is the first thing to keep in mind. Here's a simple code which I wrote to demonstrate that the models and their prediction are probabilistic in nature. So, for example, if the sentence is after years of hard work, your effort will take you, and we have to complete this sentence. I used the OpenAI API key and I ran this code which predicts the top 10 tokens and their probabilities. So, although the output will be 2, which essentially implies that the next token is 2. After years of hard work, your effort will take you 2. But you will see that there is also some amount of probability which is assigned to tokens like far, places, where, etc. So although you see these answers over here and they look deterministic, it seems that ChatGPT is very confident in giving these answers. Just keep in mind that underneath, for every single token, there is a probability, and we choose the next token with the highest probability. Usually, the distribution of the next token probabilities looks something like this. On a log scale, it looks something like this. The first token generally has very high probability in the case of confident predictions, and then the probability just keeps falling down. All right, so that's the key idea behind what large language models are. And then what exactly is this large behind large language models? To put it simply, no one really has an exact definition of what large is, but essentially there is a scaling law with size. The first paper which kind of figured this out was the GPT-3 paper. Let me quickly show that paper to you. So here's the GPT-3 paper which was titled Language Models Are Few Short Learners, where the authors essentially proved that if you increase the model size to something as high as 175 billion parameters for both one shot and few shot learning, the model performance essentially dramatically improves. I believe that this was when we truly crossed the size barrier from 1.3 billion parameters to 13 billion parameters to ultimately 175 billion parameters. And once this size barrier is crossed, we start seeing wonderful properties of large language models. So this was GPT-2. GPT-2, the largest model, had around 1.5 billion parameters. GPT-3, the largest model, had around 175 billion parameters. And in general, here is a paper which was published in Nature, right, about neural networks and size. So from the 1950s to 2020, you can see that there is an exponential increase in the number of parameters which we are using. And recently, you see the orange dots are more. This is because language models have really dominated the size space. So essentially, language models and their size has been drastically increasing, and we have reached about 1 trillion right now. So look at this straight line here, which I've shown by this red arrow. So the y-axis is in log scale. So this is an exponential scaling law, which means that the size of the language models is increasing exponentially. Why do we really care about size so much, and why do we increase the size? Well, because people have seen that as you keep on increasing the size of language models, you observe something called emergent behavior or emergent properties. These are essentially properties which are not present in smaller models, but they are present in larger models. So, for example, if you see all of these tasks here, such as performing arithmetic, word unscrambling tasks, etc., all of these tasks, you see there is a pickup point in all of these. And on the x axis, you can think of this as computational power or roughly equivalent to the model size. So, if the model size increases beyond a certain point, we have this pickup point. So the model suddenly starts learning about new things. The model starts developing these magical, awesome properties. Although the model is trained simply on the next token prediction task, as the size of the LLM goes on increasing, after a specific size, the model can do these wonderful properties, or rather, the model shows these wonderful properties like could be translation, summarization, grammar checking, etc. And that's why we are in a race to build larger and larger and larger models. Companies like OpenAI, Anthropic have even publicly said that they are just chasing size at this moment, because there is still some hope that maybe after 10 trillion or after 100 trillion number of parameters, the LLM shows some properties which we are not aware of at all right now. So these are the emergent properties of large language models. One thing to note is that LLMs differ from earlier NLP models because earlier NLP models were essentially designed for specific tasks such as language translation. Whereas, due to such emergent properties which we just saw, large language models can do a wide range of tasks such as translation, summarization, fact checking, grammar checking, etc. As all of you might have explored with ChatGPT, right? Just a key point to note, earlier language models could not even write an email from custom instructions, a task which is trivial to modern large language models. So, until now, we have seen that large language models really become better and better with size. They develop emergent properties. And one more thing to note is that at the heart of this language revolution, rather, is this architecture which is known as transformers. If you don't know what transformer architecture is, don't worry, we'll cover that in this series. But essentially, there was this paper called Attention is All You Need, which introduced a transformer architecture. It looks a bit complicated, as shown in this diagram. To truly unpack the transformer architecture, it takes um, a couple of lectures, but essentially, this is the secret sauce which powers language models, and we are going to learn about this. So, don't worry. um, Finally, one thing which I want to mention is that when we say creating a large language model, it involves two stages. The first is a pre training stage where we don't have a labeled data set, but essentially the model on its own creates training data and the labels. This is called as an auto regressive stage. So models which are pre-trained, they are also called as foundational models. So to do this pre-training, we typically assemble huge amounts of data from internet textbooks, media, research articles, etc. For example, GPT-2 was trained on data from Reddit, books, Wikipedia articles, open web corpus, etc. And then this giant large language model is trained on this huge amount of data. This training costs upward of $1 million, might even cost tens of hundreds of millions of dollars as the size of the LLM increases. Keep in mind that after pre-training, the model develops basic capabilities, and after that, we typically need to fine-tune the model. So that's the second stage. we fine tune the model with labeled dataset. So, for example, you could teach the model to translate by giving it some labels of how translation usually proceeds. You can teach the model to follow instructions by giving some instructions such as, hey, convert 45 kilometers to meters, and then the answer is 45,000 meters. That's a labeled data which you give to the model, so it learns to follow instructions. GPT 3.5, which became the product Chat GPT, it was trained with reinforcement um, or RLHF, which is reinforcement learning human feedback. So essentially, there were human annotators which graded the output, and that was passed back as a feedback to the LLM. This is very important for us because this fine tuning is a stage where DeepSeek really changed the game completely, and we are going to come to that when we see what makes DeepSeek so special. But to understand what is to follow after um, after this section, it is very important for all of us to be on the same page with respect to what are LLMs, what are emergent properties, what's the secret sauce which powers LLMs, and most importantly, the two stages involved in creating an LLM, and that is pre training plus fine tuning. With that, let's go to the next section, which is essentially what are the LLMs built by DeepSeek and how did it get so popular? So let's take a look at the different LLMs which were built by DeepSeek. So if you go to their website, which is deepseek.com, and if you scroll down to the bottom, in the research section, you will see the different versions of the LLMs which they built. They first started with a simple DeepSeek LLM. Then the significant milestones was building of this DeepSeek version 2. Then they have DeepSeek version 3, and then after that came DeepSeek R1. They released papers for each of these. So, for example, here you will see the paper for DeepSeek version 2. It's a 52-page paper. Here you will see the report for DeepSeek version 3, again 53-page paper. And here you will see the paper for DeepSeek R1. My goal in this series is that there are several amazing things which they have mentioned in these papers related to the architecture, related to the training, etc. I'm going to unpack all of that and I'm going to break it down into modular lectures so that you don't have to read this report, but rather, if you just go through these lectures, you'll understand the nuts and bolts of what is happening. The main model which caught everyone's attention, though, is the DeepSeek R1 because, as we'll soon see, DeepSeek R1 was a reasoning model which achieved comparable performance to OpenAI's top model, that too at a fraction of the cost, and plus it was open source. These were like two amazing things at the same time, right? DeepSeek R1, which was released in January of 2025, it was a reasoning model, but it had a comparable performance to OpenAI. Remember, OpenAI is closed source. This model was fully open source, which means you could literally download the model and run it locally if you have a big setup. And secondly, the API cost to this model is a tiny fraction of what the latest OpenAI model costs. And that's pretty amazing if you put these two things together, open source plus low cost. That's pretty awesome, right? Taking a look at the number of parameters, as we saw the size scaling law, language models get better with size, and DeepSeek was no exception. DeepSeek version 3 has 671 billion parameters, and then DeepSeek R1 was a reasoning model which was essentially constructed after DeepSeek version 3 foundational model was built. So version 2 and version 3 are different foundational models which they have, and R1 is the reasoning model which came from DeepSeek V3. So keep in mind this progression. They first had the version 1 which they called DeepSeek LLM, and then they made DeepSeek LLM Math, DeepSeek LLM Coder. Then they had DeepSeek version 2, and then DeepSeek version 2 Coder. Then we had DeepSeek version 3, and finally we had DeepSeek R1, which really broke the internet, and because of which we are having this lecture series at this moment. All right. So until now we have seen about LLMs. We have seen about the different LLMs which were built by DeepSeek. Now let's start getting into the uh, core content a bit, which is first of all, let's compare DeepSeek with other AI models and let's see, is it better? Why is it better? How low is its pricing, etc. So, what I actually did was, I'm very fascinated with this mathematical question because it's an amazing problem. Here is an integral from 0 to 1, x raised to 4 multiplied by 1 minus x raised to 4 divided by 1 plus x square. The cool thing about this problem, which completely blew my mind when I solved this for the first time, is that the answer to this problem is 22 by 7 minus pi. Pretty awesome, right? First of all, many of us are already confused that, oh, I thought pi is equal to 22 by 7, but that's not the case. 22 by 7 is actually greater than pi by a tiny amount, and this integral captures that amount. It's a beautiful mathematical puzzle, which was, by the way, also introduced in the 1968 Putnam competition, which is known to have very hard problems. The proof was first devised in somewhere in 1944. And again, this is a beautiful relationship, right? So what I did is I went to DeepSeek and ChatGPT and I asked them to solve this. I went to GPT 4o. I gave it this integral and I asked to choose the correct answer. Remember, option A is the correct answer, right? Let's see what GPT did. As you scroll down below, it says that the correct answer is 2 by 105, which is option B. So it spectacularly failed. Now I went to DeepSeek and I asked the same thing, solve this. DeepSeek did this step by step and I got to the correct answer, which is 22 by 7 minus pi. Although this is just one example, and by no means from one example we can compare and contrast the two, but this just shows that DeepSeek is pretty awesome at difficult problems. It got to the correct answer, and by the way, did it in like 10 to 15 seconds. Um, all right. So now let us do a bit of formal comparison of DeepSeek with other AI models. First of all, let's compare DeepSeek with GPT-4, right? In terms of performance, this is still debatable and it's hotly debated on several Reddit forums. But generally, the consensus is that DeepSeek is similar or superior to GPT-4 on several tasks. But still, performance wise, let's say you consider them to be at the same level. But the huge difference is with respect to cost, right? So, let's say if I'm invoking a DeepSeek versus a GPT model, if you look at the pricing per a million tokens, GPT-4 is around $30 and DeepSeek R1 is like $0.55. It's literally a fraction of the cost. In fact, you can even see the pricing here. On the x-axis, it's evaluation score or an equivalent of evaluation score rather, and on the y-axis, I have pricing. What you see clearly is that if you compare GPT-4o mini and if you compare DeepSeek version 3, DeepSeek version 3 is has much better performance and it's reasonably priced with respect to GPT-4o mini. But now, if you compare DeepSeek version 3 with GPT-4o, you will see that DeepSeek version 3 has much higher performance. On the y-axis, it's higher, and it has significantly lower cost if you compare DeepSeek version 3 and GPT-4o. In fact, DeepSeek version 3 seems to be vertically at the top right, which means its performance is really very good, and it's also at the leftmost side compared to all of these other models, which indicates that it's also relatively cheap. And that's what the community was extremely excited about. Here we have a highly performant model which is very cheap. And you know what's the awesome thing? This is fully open source. There is always a tension between open source and closed source models. But here is an example of a model which has finally bridged the gap. We have an open source model which is equally performant or even better than GPT-4o, which you can invoke or you can make an API call at a fraction of the cost. In fact, if you go to DeepSeek website and if you look at the different parameters, you'll see that DeepSeek version 3 outperforms GPT-4o on almost all of these parameters which have been considered over here. So the main thing is that in terms of pricing, DeepSeek completely outweighs GPT-4 because it's literally a fraction of the pricing which is there. And most importantly, DeepSeek is open sourced, whereas GPT-4 is closed source, which means you can literally download DeepSeek, host it if you have a GPU, or if your machine is big, you can host it and run it. But remember, it's like 671 billion parameters, so it's not quite easy to do this. Secondly, if you compare DeepSeek with Llama, for example, remember Llama is a host of open source model which have been released by Meta. Amazing models, but they are not quite as performant as DeepSeek. DeepSeek has great scale and performance. Its foundational model has hundreds of billions of parameters, and it has strong results which really exceed what Llama 70 billion parameter can do. So if you look at this plot again, there is also Llama here, right? And if you see in terms of performance, DeepSeek really outweighs. If you see on the y-axis, DeepSeek outweighs all of the Llama models. It outweighs the 70 billion instruct, the 405 billion instruct, because it has 671 billion parameters. Not just that, it has a lot of other innovations in the architecture, which we are going to see in a moment. Mixture of experts, reinforcement learning, training, multi-head latent attention, multi-token prediction, quantization in the input, etc. All of this really give DeepSeek an edge over Llama. Um, all right, so this is with respect to comparison of DeepSeek with GPT-4 and with respect to Llama. So in terms of strength and weaknesses, DeepSeek is pretty awesome with respect to cost efficiency. Its performance is also quite good and it's open source. These are the three biggest strengths. But the biggest weakness is that it might not be as polished or as safe as GPT-4. In my opinion, with further versions, this might get tweaked, so DeepSeek might actually become safer or more polished. But right now, that is a bit of a concern for big corporations to really implement this. Secondly, it's 671 billion parameters, right? So let's say if you are an organization who does not want to use OpenAI because you have to make an API call, so you're not comfortable with your data going somewhere else, so you decide to download and host this model locally. That might take computational resources because it's a pretty large model. 671 billion parameter is not tiny, not easy to deal with. So you need to figure out the computing infrastructure for this, but it will give you data privacy if you host it on your own server, let's say. As an organization, you must weigh these factors, right? If you really care about safety guardrails, maybe stick with GPT-4 for now and soon change to DeepSeek. If you're a lean, fast growing startup, go with DeepSeek because it will tremendously cut down costs. It is highly performant, and of course it's open source. If you want privacy, which means if you don't want your data to be going to closed source companies, again, then that would give the open source nature of DeepSeek an advantage for you. Now let's come to the main point, which is the next section of this lecture. What makes so special, or what is so special about DeepSeek? How is it able to literally charge people so less? How does it achieve so much cost efficiency and still be competitive in performance with GPT-4o? So I believe there are four major things which we need to talk about here. The first is that DeepSeek has an innovative architecture. Second is that the training methodology is very creative and innovative. Third is that they have implemented several GPU optimization tricks. And fourth is that they have a model ecosystem which favors distillation, etc. We'll see about all four of these. First of all, in the architecture itself, I believe that DeepSeek has done the following five things, right, which make it truly an innovative architecture. First, they have something called multi-head latent attention. They have a mixture of experts model. Then they have multi-token prediction. Then they have quantization. And finally, they have rotary positional encodings. We are going to learn about all of these in detail. In fact, going into each one of them itself will take two lectures. There is very limited information about all of this on the internet, and it just you need to spend a lot of time on each of these to truly understand the architecture innovation. Here, let me give you a quick flavor of what each of these actually mean, right? So, if you go to the original attention mechanism, which I showed you in this paper, which is attention is all you need, there was the multi head attention mechanism, which looks something like this. Uh, which looked something like what you're seeing in the figure right now, right? This is the multi head attention mechanism, which was there. Now, DeepSeek, what they did was they introduced something completely different. In order to make sure that the attention mechanism is implemented effectively, they had a key value cache, but instead of a normal key value cache, they had a key value cache in a latent space. Don't worry if you don't know what these terms mean right now. We will cover all of this in subsequent lectures, but just make sure that, or for now, you should understand that they did this special type of caching, special type of key value caching in the latent space, so that the attention mechanism computation becomes much more efficient. It takes up less space and it's computationally also fast. That's one change which they made. So this was the multi-head latent attention, which was the first thing which we discussed. The second thing was with respect to mixture of experts. So if you see the normal attention mechanism, it looks something like this, right? There is a feed forward, there is the attention layer and followed by a feed forward neural network after the attention layer. And the feed forward neural network looks something like this. In a mixture of experts model, what you essentially do is that you have four experts. The entire neural network is not activated at once, only parts of the neural network are activated. So there is a special routing mechanism which actually decides which part gets activated and which part does not get activated. This is the router which essentially decides which expert is going to get activated, which expert is not going to get activated. We are going to learn about all of this also in a lot of detail. This is another key innovation which they implemented. Third is multi-token prediction. As we saw at the beginning of this class, that usually we just predict a single token, right? They implemented a new thing which was discovered in a paper released just last month, that why don't you predict multiple tokens instead of one token? What if that speeds up the process, makes it more efficient? Then fourth thing is they implemented quantization. So instead of representing every parameter as a large floating point number, you just represent it in a slightly compressed manner. The best way to think about quantization is like here, right? In the original image on the left hand side, there are a huge number of pixels. Whereas on the right hand side, the image is just constructed out of eight colors. So it's kind of pixelized. So if you zoom in, it's completely pixelized. See here, it's pixelized over here compared to the left hand side, which is very sharp. But if you zoom out, you will see that it almost looks the same, right? So this is called as quantization, and they implemented quantization in the parameters of the transformer block. And then finally, they have something called rotary positional encodings. So let me show you the rotary positional encodings right now. Essentially, in the attention mechanism, which was published in 2017, they just added positional encodings to token encodings, which polluted the embedding vector. But soon after that, people realized that why don't we just rotate the original vector, the query and the key vectors, to capture the effect of positional encodings, so that will not change the magnitude, and that's a highly efficient way to encode positions. So instead of encoding positions in the token embedding itself, we encode it a bit later in the query and in the keys. So yeah, this is with respect to the rotary positional encoding, which is the fifth key innovation which the DeepSeek architecture implemented. We are going to look at all of this in a lot of detail. Now, this was the first aspect, which was innovative architecture, but they did not stop there. I believe the DeepSeek paper truly makes the field of reinforcement learning reborn, because instead of just relying on human labeled data like we saw for GPT 3.5, where humans graded the quality of the data and that was fed back to the training process, what they did is they used large scale reinforcement learning to teach complex reasoning to the model. And instead of human labeled data, they had a rule based reward system. So it was not relying on human judgment, but purely it was a rule based system. Through this, they implemented a framework which is called Group Relative Policy Optimization, which is at the heart of the reinforcement learning training mechanism which they implemented. We are going to learn about all of this, which this is the main reason why DeepSeek R1 is such a good reasoning model. So, reinforcement learning is a major part of what we will be covering. The third aspect is GPU optimization tricks. Now, this is a bit tough to understand, so I'll not be spending too much time here, even in the course. But essentially, what they did was instead of using CUDA, they used something called NVIDIA's parallel thread execution. The simplest way to think about this is that, uh, in fact, I asked ChatGPT what's the simplest way to think about this. So, if you think of CUDA as writing Python or Java code, PTX is like one lower below. So it's an intermediate step before machine code execution, and that just speeds up things a lot more. So in high level programming, you are not at the machine code level, right? If you are at the machine code level, it's the fastest, like C or C++. Whereas Python or Java takes you to a high level that slows down things. You can think of PTX as somewhere in the middle, whereas CUDA is at the higher level, but PTX is at the middle, a bit closer to the machine code execution. So that speeds up things a lot more. There was also a nice article published about this. Yeah, DeepSeek's AI breakthrough bypasses industry standard CUDA for some functions using NVIDIA's assembly like PTX programming instead. So I believe that also played a major role in speeding up their or making their architecture a lot more efficient, and which ultimately reduce the costs. And finally, they have a strong model ecosystem where, although the main model is 671 billion, they have distilled it down to smaller models, even as low as 1.5 billion. That makes it a pretty awesome model ecosystem. We are going to look at model distillation also. So, just to recap these four aspects which make DeepSeek so special, first is the innovative architecture, second is the training methodology, which is centered around reinforcement learning, third is the bag of GPU optimization tricks which they have, and fourth is model ecosystem, especially distilling from a larger model into smaller models as small as about 1.5 billion parameters. Now let's come to the last two sections of today's class. First is, why is DeepSeek such a turning point in AI history? And I believe it is a turning point because of the following reasons. It is the first time that a small, scrappy startup has reached parity with the best AI models using novel techniques and far less resources. They have slashed down the development cost. Although it's not as low as $6 million, I believe it's still quite low compared to what big corporations like GPT or Meta's Llama, etc., the cost requirements which they use to train the models. So it's like it was the first proof that even small startups, even companies which are not maybe as funded as OpenAI, can build a large language model which is awesome, right? Which performs at par with GPT-4, it does so with far less resources. What also happened with this is that people got scared, right? Investors got scared. There was a huge dip in the US tech stocks in January 2025 because of DeepSeek's advancement. The main reason was the idea of a low cost, open source Chinese AI model threatened the profit models of OpenAI, Microsoft, and even Google, and raised concerns about the AI supply chain and GPU markets. One model or one company, DeepSeek, brought about so many changes, and that's what makes DeepSeek a turning point in history. One major thing which I believe has also happened because of DeepSeek is that developing countries, such as for example India, have heavily started investing into building their own large scale foundational models. If China's DeepSeek can do it, then why not other countries? Why only US, and why only companies coming out of US rather, right? Why not other companies with resources which DeepSeek used can build their own foundational models? So all of this discussion has been started. In fact, the Indian government has also released a call for building foundational models. That's pretty awesome, I think, and it's one of the main motivating factors for me to create this series. Now let's come to the last section of today's lecture, which is our plan for this lecture series. We have developed, or I have rather divided this lecture series into four phases based on what is the speciality about DeepSeek. The first phase for us is going to be going into the architecture. So first I'll start with the attention mechanism. Then I'll go into multi-head latent attention, mixture of experts, multi-token prediction, quantization, and rotary positional encodings. I am going to assume that you have some amount of knowledge of attention. If not, you can check the Build LLM from Scratch series. So this series is going to be a bit more advanced, and it assumes that you go through that previous series before. I am going to start at a slightly higher level here. Then we are going to go in the phase 2 in the training methodology. Phase 3, GPU optimization tricks. This will be a small phase. I won't be having too many lectures here. And then I'll conclude with lectures on distillation. A bulk of the lectures will be on phase number 1 and phase number 2, and smaller number of lectures on phase 3 and phase 4. So this is the main plan which we'll be following for the series. Let me quickly summarize what we learned today. First, we looked at large language models and the fact that they are engines of probabilistic next token prediction. We saw that size is a very important factor in large language models. There is a size scaling law. As the size increases, the models get better and better. They start developing emergent properties which are not present in smaller models. Then we saw that the LLM secret sauce is essentially transformer, the transformer architecture. And then finally, we saw that creating an LLM means building a foundational model, which is essentially the pre training stage. And then we have a fine tuning stage. There are two parts. Then we saw that although DeepSeek R1 has become popular, the DeepSeek company started long back. They started with the DeepSeek LLM first, which is version 1. Then they had version 2 and ultimately version 3, which was a huge model, 671 billion parameter. And then ultimately they made DeepSeek R1, which is a reasoning model, and that broke the internet. Why did it break the internet? Because DeepSeek R1 has comparable performance to OpenAI's top model and at a fraction of the cost, plus it's open source. So DeepSeek is equally performant as GPT-4. Their pricing is literally, I think, 100 to 500 times less, as I showed you in this lecture. And finally, it's fully open source. Um, Strength and weaknesses. The biggest strengths of DeepSeek are that it's open source, it's cost efficient, and it has competitive performance. So three big strengths. The biggest weakness might be that it's not maybe as polished or safe as, let's say, GPT-4 or Claude. Another weakness is that if you're planning to deploy it locally or planning to use it securely, you need to have infrastructure for downloading and using a 671 billion parameter model. Then we saw what makes DeepSeek so special, and there are four key ingredients here. The first is the innovative architecture, training methodology, GPU optimization, and model ecosystem. Within the training or within the innovative architecture, we have five key things: multi head latent attention, mixture of experts, multi token prediction, quantization, and rotary positional encodings. Then in the training methodology, we have the fact that they used large scale reinforcement learning to teach complex reasoning to the model, and they used a rule based reward system, which is also known as group relative policy optimization rather than relying on human label data. In the GPU optimization tricks, they used parallel thread execution PTA instead of CUDA only in some places, I believe. And then finally, they have a strong model ecosystem where they distill their main model into smaller models as low as 1.5 billion parameters. In this lecture series, we are going to follow the same workflow. We'll go with the first phase, which is innovative architecture. Then we'll go to the second phase, which is training methodology. Then we'll go to the third phase, which is GPU optimization tricks. Then we'll go to the fourth phase, which is model ecosystem. I am going to assume a good amount of knowledge about LLMs, and I will explain the attention mechanism again, but I'll essentially start from the attention mechanism and then dive into the details. If you're a complete beginner, I recommend the Build LLM from Scratch series first. And then finally, I believe DeepSeek is a turning point in history because they literally showed that even developing countries can build their own foundational model. If we are smart about the innovative architecture, if we are creative, we can build a foundational model which is as good as, let's say, OpenAI's models, and that too at a low cost and fully open source. So they are truly democratizing AI that way. So thanks a lot, everyone. And I look forward to seeing you during the next lecture. Thank you.